What are artificial neural networks? Are they really made of neurons, like our brains? The structure of artificial neural networks presents a starting point in our pursuit to understand them, but says very little about their capabilities and limitations. For this, we must dig deeper and ask more pointed questions. Why were they invented, and what kinds of problems can they solve? How do they know things? Can they learn on their own, or do we have to teach them? In this chapter, we dedicate considerable time to understanding artificial neural networks and their history. Their origin story is one of optimism and hope. As you might imagine, the artificial neural network, much like our own brains, began its life as a single cell. Complex networks developed from that cell, and these networks are today's rock stars of artificial intelligence. We use them for making sense of data. We use them to classify images, performing object recognition and tracking for self-driving cars. You might have seen a Tesla successfully merge from one lane to another without human intervention. The car has cameras and other sensors that help it capture the state of the outside world. But artificial neural networks are tasked with interpreting the data from its sensors to identify vehicles, pedestrians, traffic signs, road signs, and anything else that enables it to see the world. Researchers are currently investigating using neural networks in medical settings as image classifiers to help diagnose different kinds of diseases, from melanoma to breast cancer to pulmonary ailments like pneumonia. For example, neural networks may be tasked with identifying anomalous regions in image scans of biopsied tissue, or signs of pulmonary effusion in X-ray images. In a more general sense, we use artificial neural networks to process large volumes of data and extract patterns and trends from the data that might be significant to us. In some cases, this involves analyzing images, but neural networks are not limited to vision applications. We might train a neural network to predict the price of houses in certain neighborhoods, or teach it to analyze financial markets' historical data to forecast future trends. In other words, we use artificial neural networks as tools to solve certain classes of problems, namely classification problems and forecasting problems. But the history of artificial neural networks, in some ways, is not the pursuit of a tool for artificial intelligence. It started with researchers' need to understand the human brain. Researchers like to use analogs and models to investigate concepts. It is difficult, however, to tinker with a real brain. People get in the way. Early researchers in neuroscience and psychology thought it would be useful to try to build an artificial brain as a step to understanding our own. To try to answer the questions we opened with, this chapter is broken into a few sections. We start by taking a stroll through the halls of history and examining the earliest steps in the 19th century that contributed to building a functioning artificial neural network. We discuss how researchers came to view the neuron as the key element in information processing and look at the first artificial neuron, the McCulloch-Pitts neuron. We explain how developments in our understanding of the biological brain contributed to modifying the McCulloch-Pitts neuron into a more powerful system called the perceptron, which led to the simplest type of artificial neural network, the fully connected neural network, also known as the multi-layer perceptron, or MLP. See Figure 1.1 in the accompanying PDF. We explain why, although artificial neural network research began in earnest in the 1950s, you probably didn't hear about such networks until very recently. Research in the field suffered many ups and downs from its inception, with many of the downs driven, in part, by overhyped promises. We try to make the case that while hype is still a problem, it looks promising that artificial neural networks will stick around. Once we establish the progression of steps that led to modern artificial neurons, we examine how these neurons can be combined into complex networks. We look at examples and explain how information is processed by each neuron in the network and how the output of the network is calculated and interpreted. Finally, we close the chapter with a few use case examples for how we can employ neural networks to solve real-world problems.